Our next talk is from Arize, and one of the hardest things about LLM applications is evaluating them appropriately. Aparna, who will be speaking from Arize, and the rest of the Arize team have been working on building LLM evaluations that really work in real-world scenarios. And Aparna, I will bring her up to the stage so that she can talk about how they are doing that. Okay, I think Aparna, you're up on stage, but you're muted.
Hey, can you guys hear me?
Yes.
Awesome. Awesome. Well, hey, everyone. So excited to be here. Well, let me jump in and let's get started on our talk today. Let me go ahead and share my screen. Okay. Can you guys give me a thumbs up if you can see my screen?
We can see
right
it
now. Awesome. Okay, I can't see what I'm sharing, so keep me honest if something freezes up here. So awesome. So today's talk, what we're going to be talking about is building LLM evals that work in the real world. You guys have probably seen this. This is from Greg Brockman from OpenAI, but truly do believe in this. Evals are often all you need, and there's a lot of ambiguity around what are evals, what should I be using, and we've been dropping a lot of research about different approaches. And so I'm going to be giving you guys an overview of kind of the research we've been sharing, as well as best practices around how to use the evals. So first off, I think the word evals is overloaded when there's really two types of evals that we're hearing in the market. There's model evals versus task evals. Model evals are the ones that, if you go to Hugging Face and you look at the OpenLLM leaderboard, or Berkeley Function Calling, the Gorilla team has done one that's around specifically function calling. But they really rank up different foundational model providers and help you decide which model to choose. And all of these use metrics like MMLU or the hella swag, but these are types of metrics that are focused around what model do I actually choose for building my application, and which models might be better at things like RAG or retrieval width generation. And so there's model evals and there's also task evals. If you're an AI engineer, the one you probably care about, if I'm honest, is probably the task evals. You might use the model evals just to help you figure out what model to use, but day in, day out, the one you're going to care about is probably more of the task evals. This is really the ones that are helping you answer, is my application working? So there's metrics like correctness, hallucination, product-specific metrics that you might care about way more. As a day in, day out, how do I improve my application? But both are important to different folks. These are slightly more important to folks who are building foundational models or even fine-tuning them. These are slightly more important for kind of the folks really building the AI applications. And there's a lot out there on the model eval side to help you pick the right model to use. One of the most popular ones that blew up a couple months ago was really the needle in the haystack approach, which was basically a test on how well different foundational models were at retrieval. So something like this, where I had a long piece of context and I would put a piece, a fact hidden somewhere in the long piece of context. And the goal was for the foundational model to be able to retrieve that piece of context. And the hard thing here was that you could increase the size of the context window. So we had some that were tested when they were really, really small context windows. A lot of the foundational models did well. As you increased it, obviously it got significantly worse. And then it was also placement within the context window. So in this case, it's kind of earlier in the document. And then here in this case, it's kind of 90% of the way down, further into the document. And the goal here was, did placement within the context window actually make it harder for some of the foundational models to retrieve the data? So here, basically, the x-axis is the context length. So how big was the document? And then the y-axis here is actually the placement within the document. And we were testing basically how good was a number of different foundational models. So this was actually Claude 2.1, not the latest one. This is not Opus, but Claude's 2.1 compared it against GPT-4. And you can see here, this was kind of the previous model, but specifically as you increase the context length and then the kind of further and further down, it went inside of the actual document itself. It had a really hard time retrieving that fact. Green is where it got it, red is where it actually didn't get it, versus GPT-4 did generally good, even as you increase the context length. But there was this kind of consistent, even as we ran multiple tests, consistently at the front of the higher window during higher context lengths where it was challenged. So what it meant was if you put the context or the facts earlier in the context, it almost forgot it before it forgot it and didn't do a great job of using that fact in the actual retrieval. And so these are really helpful just as you're building out your RAG systems to understand, okay, well, which one should I use if I'm trying to have a long context window or a short context window? Where am I placing it in the document? These are helpful ways for you to understand, well, what type of foundational model should I be using? We did another one, which is focused around retrieval, but this time also generation. So after you retrieve the fact, could you do things like generation on top of it? Could you round the numbers? Could you concat them? Simple date mappings or modulo numbers. And we tested this again on a couple different models, GPT-4 Turbo versus Anthropic Claude. This was one actually in the beginning. Claude did significantly better, almost 4 times better than GPT-4 did. And GPT-4, even though it did the right retrieval, it missed the generation part of it, versus Claude, despite all the issues on, we were seeing with 2.1 on the retrieval, actually did a fairly decent job at the generation. And actually, after we modified the prompt a bit, we were actually able to improve and fix GPT-4 Turbo's performance almost significantly. And the key thing we just added was just a line that said, please explain yourself and then answer the question. And the reason this is really important is because I don't know if you guys have all felt it or seen it, but the Anthropic Claude models are slightly wordier. We see that in market, slightly wordier than the GPT-4. But in this case, it might actually be a feature, not a bug type of scenario, because it was wordier, it was actually checking itself along the way, which got it to do much better than GPT-4's original response. And we had to explicitly ask GPT-4 to do this in order to get a better response. And so if you're using GPT-4 for retrieval with generation, adding these types of things inside of your prompt will actually help you improve the response that you're actually trying to gather. These are just a little snippets of some of the model evals that we've been releasing. Again, probably more important as you're actually picking the model, if you're an AI engineer, helping you decide which ones to worry about. But the key things that we see more people care about is more of the task evals. On the task eval sides, there's predominantly kind of 3 approaches the industry has landed on, which is LLM as a judge. So these are where you're actually using an LLM to, using AI to evaluate AI. There's a number of common metrics we'll go through. There's user feedback. This is things like thumbs up, thumbs down, good, bad, but actually having a human in the loop. And then there's very heuristic code-based approaches that are also really great for things that you need a very, very programmatic approach to be able to do. For those of you who are not familiar with LLM as a judge, I'll just do a quick overview of it. But LLM as a judge is basically you're passing in at your application prompt. This is actually the prompt into the application. You generate a response from it. And then you use basically all of the information that was sent into the prompt or the response, depends on your template. But in this case, for my hallucination template, I'm actually using kind of, is the response that was generated based off of the context that was actually used to answer the question. And so in this case, this was all actually used, passed in as the LLM as a judge to evaluate the response. And it kind of came back with, no or yes, it did hallucinate. Really, to use these methods, you want to do benchmarking on the eval templates beforehand. So you want to make sure that the LLM is is has a pretty decent precision on what you're actually trying to evaluate, and then continuously validating these validators. By the way, great paper by Shreya Shankar. But it's a really important thing to make sure you validate the validators that you're using. Common thing that we recommend and we see people in the ecosystem doing is actually using these evals with explanations. So what we mean by that is not just getting a single label, correct, incorrect, hallucinated, not hallucinated, but actually using explanations to surface up if it was incorrect. Why was it incorrect? In this case, it actually tells you, well, it's incorrect because it does not answer the question based on the reference text. And so it actually gives you a next step to go do around, all right, well, what was the reference text that was actually used? Why did it make up information or not use that information? And so they actually give you kind of nuggets on why it made that label, and then how to go fix it in reality. There's a lot of different types of evals out there, some which are focused around, there's different categories of eval types that we see in the market used for task evals. Some are numerical based, categorical, multi-output, just means you're using the eval to run multiple evals at the same time. So things like, is the summary correct? Is the summary concise? Is the tone consistent? Is the tone positive and not negative? So these are all things that where you can have multiple labels coming out of those evals. And there's also, of course, multi-class labels. So give me multiple different categories as outputs. What we're seeing in the ecosystem is actually that we really actually recommend folks not use numerical scores as the only form of eval that you should use for your application. And we'll show you kind of what we've done some research on and some examples. This is a simple application that is just supposed to judge how good is how many spelling errors are in a document. So in this case, it's supposed to give you a score between 1 to 10. Tell me how bad the spelling errors are in the document. And we actually corrupted this document with kind of 80% of the document had spelling errors. We also similarly did another document that only had about 11% corruption. So very less compared to this one. For both of these, the eval score the LLM as a judge gave was 10. And what made it really difficult was that there's really no sense of granularity between these two different documents. Both of them, when you're doing a numerical score, you get this kind of sense of, okay, there's a gradual as it's worse, the score is higher, as it's less, the score is lower. But we actually didn't see that. And this is it was pretty consistent across a lot of foundational models, where even as we increase the density of the corruptions, we actually saw a pretty binary type of response. It was either a 1 or it was either a 10. But what we really wanted was more of this like gradual, perfect linear range. And that would have signaled more that, okay, LLM as a judge can be used for numerical scores and it understands the gravity increases as the score increases. But it almost suggests that the scores itself were coming back binary. It was really suggesting for us using it, you should kind of use it more as categorical binary labels instead of numerical ones. I think we have a good 10 minutes here. So what I'm going to actually do, hopefully that was helpful. This is all kind of cool research you've been sharing on Twitter about what we're seeing in the ecosystem. I'm going to jump actually into what we're seeing with customers and what we're seeing in the real world as people are building these task evals. There's really a workflow here that we're seeing across the life cycle of building these evals. There's a phase when you're actually benchmarking the evals. So this is as you're building your eval templates, you're building the golden data sets, you're using them to actually understand how much should I trust this LLM as a judge template? And not all templates are going to be right for your use case. So there's definitely a benchmarking on your own golden data set for your own domain specific application that needs to be done. Once you're actually done benchmarking that eval template, as you're actually iterating and developing your application, we see folks using those evals in development as well as in production. And that line can get really blurry. They start to iterate on the prompt, they start to iterate on their, swap out the model, swap out what you're doing for the retriever. And every time they make modifications, they want to rerun those evals to make sure that that experiment did better or worse than prior. And then they want to use those same evals when the model or the application is actually deployed into production to be able to run that in a production application and monitor the performance of the number of hallucinations that's happening in production. So these evals are actually, you want to use the same templates and often for folks the same frameworks to be able to run offline, but then also run them online in production. And this can be for really simple applications, but applications can also get really, really complex. This is, I almost call this a little, the agentic or pre-agentic type of workflows where folks are actually using routers to determine what is my user intent, and then all sorts of different paths that the user can go down. So everything from product comparisons, product search, if you're doing something like an e-commerce bot. And so these applications can get more and more complex with LLM, internal API calls, code, and being able to evaluate these type of router-based applications require really levels to these evals, is what we're seeing in real data in the real world. And so what I might actually do is jump in and show you guys a demo of how this actually looks in a real system. So let me actually show you guys Phoenix and demo and show you guys how we think about evaluations. So, oops, let me go back home and pull it up. Give me 1 second here to pull it up. Can you guys all still hear me and see my screen?
We can hear you, yes, but we cannot see your screen.
Okay, awesome. Give me 1 second just to pull it up, and then I'll go ahead and share my screen again. 1 second here. Okay. This might take a second to load, so let me give it a second to load, and if it doesn't, then we'll just rerun it so that we can, oh, perfect, okay. It is running. Okay, awesome. Let me go ahead and share my screen here. Okay. All right, sounds like I'm sharing again. Okay, so basically this is the e-commerce bot that I was kind of showing beforehand in this view over here. This is actually a really common type of use case we're seeing folks build. What the use case is basically someone as a user comes in, they might be, asking a question, and the question should route to a couple different paths. Help me compare products, help me search products, help me maybe route me to customer support. And so under the hood, what's actually happening, this is, let me show you an example. Users come in and ask, hey, is there some way to apply a discount code to my recent purchase? And what it does, oh, I think I really need to rerun this application here. Give me a second. Maybe while that's loading up, let me just show you guys in the application here. Behind the scenes, what's actually happening is a function call. So there's a router that is actually routing to which execution branch to really go through. And what you want it to do is basically, from a router perspective, route to the right execution branch. You don't want, when the user is asking or if there's a product support question, have it go and recommend products to you. And so there's levels to this evals where at first you want the router eval to actually work and get what the user intent is. And then post that, you want it to actually go down the right execution branch and make sure that it actually answered the user's question in that execution branch. And then each execution branch itself might have multiple different components. So if you're doing something like a product comparison workflow, you want to make sure that every single component where it queries what products from maybe the vector store or from the catalogs, it actually queries that, gets that information correctly before it shows it to the user. And so this is a really common type of, call it application, that we're seeing in the ecosystem, where it's called router-based architectures. And for these router-based architectures, basically there's typically a function call. And the function call is what, first determining based off of what the user asked, what should I even call? In this case, this is a asking for specifications on the product. And so it should call a product details function call. This one's asking for differences between two products. And so it actually should be a function call around, a product comparison. So it got the function call wrong. In this case, it's actually asking about recommendations. So you want it to, again, go back and do a product search. And so there's first a level, which is just, did it call the right function? And the next level of this is, if it calls the right function, did it actually get the parameters for that function correct? So if you're doing things like, in this case, you're asking for a specific product, you get the product ID, that's the right parameter. In this case, there's actually two parameters. And one of them is the actual query, and then what category of products are you asking it to search? And I'm not sure if laptop probably fits into office supplies. Maybe they expected it to be more in electronics. And so this is one where it actually got the parameter for the function call wrong. And so you might want actually multiple levels of evals on what function did it first call, and then did it actually extract the right parameters for that function eval in the right way. And each one of these, you can actually do LLM as a judge. You can track things like the precision and the recall of these different types of applications. And we're seeing this as a very common framework that folks are doing to actually route some more complex applications like this to the right experience for the user in the real world. Another common type of experience here is if you have multiple back and forths with the user. So something like a session, you also have the session with, the user talks to the bot, and then the user comes back and asks follow-up questions. Then you can actually do things like, across multiple messages, was the tone consistent? And then within each individual message, did it actually answer the question that the user had just asked? And then, of course, within this individual kind of back and forth messaging, there's also a lot of sub steps or spans that could have happened. So to answer maybe even in a single question, there's a retrieval step that needed to have happened to answer that. And so there's just levels to these evals. And I think when we often talk about evals as a high level concept, we think it's maybe just one at the end of an application. But in the real world, these applications are often really complex, can be really, really multi-step. And so it's really important for the owners of those applications and the builders to know what's important to evaluate and what's important to actually track when there's failures in the application. I'm going to go ahead and see if I can get the thing pulled up one more time so I can show you guys. See, live demos. Okay, awesome. I think I have a good example here to show you guys. Okay, let me go ahead and pull this up. Okay, awesome. So For those of you who aren't familiar actually with us, this is Arize Phoenix. You can go check it out if you just go to docs.arize.com with Phoenix. It's completely open source evaluation and observability framework. You can use it for things like first off, tracing your application, so actually seeing what's happening under the hood, but then also, of course, applying things like evaluations to every single step of your application. So in this example here, this is kind of the one I was sharing of where the user asked a question. So the user asked something like, I ordered a device. I'm not sure if it was this. Can you help me track it? And in this case, what it does is there's actually a function call. So the function call is actually deciding what specific call to make. And so if I go over and I can see in this case, it did a product comparison function call. The ones it has access to is product comparison, there's product search, it has access to customer support, of course, track package. And so these are all the ones that it actually has access to, and it can decide across those different, so similar to what we're showing over here, all of these different execution branches that it can actually go under, and then deciding which one should it actually use to go down the path of. And what you can do is apply evals to see where did it get it right and where did it not get it right. So I'm gonna actually go into one where there's an incorrect function call, and we can all take a look at that. So in this case, someone's asked a question, is there any current promotions for the Samsung smartphone? Let's go into the evaluations, and it looks like it said it made an incorrect function call. It actually made a product search function call here. But the user was specifically asking about promotions. So if I look here, it gives me kind of the function calls incorrect. The user's questions asking about promotions, but the generated function call is for a product search, which may not specifically address promotions. A more appropriate function might be the one that directly queries promotions or discounts. And so having the traces first helps you see in these slightly more complex router-based applications, or if you're using agents, essentially, did it go down the right path even? And then if it didn't go down the right path, where did it mess up? And we have teams that then look into, well, should I be adding more things to user, either the descriptions of the functions or adding data, adding into the prompt templates to make sure that it routes to the right function call. But if it doesn't get this step correct, it's not going to get the rest of the flow correct. And so definitely making sure as best as you can that you have things like function calling evals, having the ability to go do the right parameter extraction is really important to give it all of the data it needs to be able to choose the right path. One last thing I'll just showcase here, and we can see if this gives you guys a little bit of view into it. But when you do have basically, and again, this is Phoenix, you can kind of use it to trace your application, run your evals, apply it onto it. But what you can do is actually add these types of bad or incorrect examples into data sets. So if I wanted to, I can actually add it to things like data sets that I can then go use to iterate and improve on my application. So in this case, I've actually already created a couple different data sets, but I can go in and just add this if I wanted to an existing data set. And what these data sets essentially allow me to do is then run experiments. So I can run experiments where I'm doing things like iterating on the prompt template on those bad examples, or iterating on the function calls, however you want to make those changes. And then you can compare side by side against what was the generated output versus what was the actual reference output. And these end up being great because, like we were going back to talking about it, evals are not just used in production. They're definitely helpful as you're developing. And so having these evals to iterate on your experiments and improve the application, ultimately make it better. I think I'm getting close on time, so I'm gonna actually stop share here. Hopefully that was, a lot of information that it's helpful for folks out there who are building and are actually trying to build these applications. If I could leave you with a couple of takeaways, the key ones would just be, first, know the difference between model evals and task evals. That's really critical. Second, for task-specific evals, depending on how complex your application might be, you're going to need, don't assume it's just a single eval. You might need evals at different steps of your application. So figure out what those should be. And then third, as you're building these task evals, generally recommend don't use or don't just rely on the numerics for evals. Make sure you're actually benchmarking them and testing them to give you the right types of evals for your use case. Awesome. Well, let me know if there's any questions or any other notes.
Thank you, Aparna. Eugen, I think you asked a question. Was that for Aparna?
Yes. So actually, I think we've got two things for you, Aparna. So yes, what is pressure testing? I saw that in the slides and I was like, I don't know what this is.
Yes. Okay. So pressure testing is basically, I hope I'm not on mute, but pressure testing is basically, I probably said it when we were showing some of the model evals that we were doing in the market. So we were pressure testing basically how good Anthropic Claude 2.1 was against GPT-4 on Needle in the Haystack. So we were testing it on basically how good was it. We placed the fact, and then we tested it across different context lengths, different fact depths within the document. And I mean, we think about it basically, the parallel I would say is like if you're profiling code to figure out where it's really slow. In this case, we were basically profiling for specifically retrieval where retrieval was really poor for these two different types of foundational models.
Okay, very cool. There is one other question.
Has your research included evals where the user is prompted for what the inferred parameters are, i.e., so you are interested in promotions?
Yeah, that's a great question, actually. So basically just assuming kind of this is what you're asking, but basically in this case, the words that might be used, like in the question, such as, are you interested in promotions? If the user specifically asked for that, well, then why not just go to that function call? Why are we kind of making the LLM decide what function call it actually should? This is actually something that could be covered in the parameter evals, the James skin, I guess. This is actually some of the templates that, let me go over to the deck here, but like I was mentioning that there's a couple different types of, even within a function call, there's like the eval on the function call, but then there's also the eval on the parameter extraction. So did it actually get the right inputs to go into the function from the user input itself? It just depends on, some of these function calls can have similar parameters. So not always just, like in this case, we actually had one where it was product details and then also track package might have had something like the same, they might both have like an ID field. And so just the difference in those parameters doesn't always make a difference. And then you have to know first what content in the user question should actually be the right thing that's pulled in as the parameter. So it's actually a lot of places where this can go wrong. And so it's kind of hard just to test it based off of, keywords or something like that. I don't know if that answered your question, but hopefully it was helpful.
All right. I think that was it. Thank you so much, Aparna.